Hello viewers, I welcome you back to Easy Mathematics. Today we want to continue with our lessons on change of subject. Previously, we've talked about change of subject in relations involving fractions. Today we want to continue and look at relations involving square roots and squares. Now, these two are used interchangeably. Before we look at an example, anytime you are making a variable the subject, okay? Now, let's begin with a square. If the variable you are making the subject has a square on it, make sure that that variable stands alone at one side of the equation. When that variable is alone, the variable that you are making the subject is now alone on one side of the equation because it is squared. If you want to get rid of the square, you are going to introduce the square root on both sides, okay? Now, once you introduce the square root on both sides, the square will now be cancelled by the square root. And the same thing happens that when I'm making a variable the subject, and that variable has a square root, I will square both sides. So using the square and the square root when it comes to change of subject, they are used interchangeably. Once you square, or once there is a square root, you square both sides. And once there is a square, you square root both sides. So let's take an example, or let's look at the examples that we are solving today, so that it can help us to know how to change a subject in a relation involving roots and square roots. Now let's look at the first one. The first one is saying that make t the subject in the relation v is equal to x plus mt squared. So this is the given relation. The relation we have been given is v is equal to x plus mt squared. Now you can see that the variable I am solving for, or the variable I'm to make the subject, has a square on it. Now, how do I let the variable stand alone? Now, whenever you have an equation like this, the term with the variable you are solving for, let that term be alone on one side of the equation. So I want the mt squared to be alone. Now in doing this, I will therefore take the x to the other side, which will give you v minus x is equal to mt squared. Okay? Now the first thing is, I'm to target the term with the variable I'm making the subject. So this is the term I am targeting. Now if you target that term, let that term stand alone on the equation, or at one side of the equation. So this is the term having the t that I want. So I'm therefore going to make that t with, or that term, stand alone at one side of the equation. Good. Now once you are able to do this, the number attached to the t, which you don't need, you can see that the m is multiplying the t squared. So because I don't need the m, what do? I will divide this side by m and divide this side also by m. The aim is to let the t stand alone, but the m is multiplying the t. So because the m is multiplying the t, I will divide this by the m and also divide this by m. So now I have v minus x is equal to m will cancel m, then all over m t squared. So you can see that now the t is standing alone, but the t is not alone, the t is squared. So I have to get rid of the what? Of the square. So as I was saying in the beginning, if you are making the variable the subject and that variable has a square, if you want to get rid of the square, square root this value. But because what you do on the left hand side, you do the same at the right hand side or vice versa, I will square this and also square this. Now the moment you take the square root of both sides, the square root will now cancel the what? The square. And now I have the square root of, remember the square root is for everything. So the square root of v minus x all over m is equal to t. So now if I should write this vice versa, t is now equal to the square root of v minus x all over n. Remember in our introduction when we began with the change of subject, we look at how to make the change, how to change a subject having a relation like this. Now it is the same relation, but this time the variable we are solving for has a square. So if it has a square, under normal circumstances, my answer would have been t is equal to this. But because it has a square, I have to get rid of the square. And how do I get rid of the square? To get rid of the square, you square root both sides, provided the variable which you are making the subject is standing alone or it is on its own, and you want to get rid of the what? Of the square root. It is very, very important to get the understanding of the introduction with this very relation. That once the relation involves square or square root, our target is the term with the variable we are interested in. So I will first let the variable stand alone at one side of the equation. Now mt squared, this mt squared, I don't need the m which is multiplying the t squared. So I will divide both sides by m. When I divide both sides by m, the m will now cancel out, leaving behind t is equal to, which is the 12, the t squared is equal to v minus x over n. But because the t is squared, I will square root both sides so that the t will stand alone at one side of the what? Of the equation. Now remember that once you square both sides, or once you square root both sides, the square root is for everything at this side. So it is affecting the numerator, it is also affecting the denominator. And that gives you something like this. You'll be able to make t the subject. Good. Now let's look at the second one in relation to this. Make r the subject. You have the relation a is equal to pi r squared. You are making r the subject. Now the r that I'm making the subject, here you can see that this term is alone, and this is the term that contains the variable I'm making the subject. So I don't take any value to the other side. But this term that I have here, pi is multiplying the value I want, the variable I want. So since it is multiplying the variable, I will divide both sides by pi. So that I will therefore have a over pi is equal to r squared. I want r to stand alone, not r squared. So because I want r to stand alone, but the r is squared, what do? I will introduce the square root so that the square root will get rid of the square. So I am going to take the square root of the right hand side and also the square root of the left hand side. So the square will cancel the square root. Now I have the square root of a over pi, which is r. And this implies that r is now equal to the square root of a over pi. So now I have made ar the subject. Remember we said the subject is the variable you are solving for. It is a variable that stands alone or stands on its own at either side of the word equation. So if the square root is introduced, the square root will get rid of the square so that calculation can be what? Simple. Let's look at the number 3. The number 3 says, if p is equal to m over r squared plus k, express r in terms of p, m, and k. Now, we also said that another way of saying make a variable the subject is express that variable in terms of other variables. So I have p is equal to m over r squared plus k. Now, this would now look like a relation involving fraction. Though it has a square, it involves what? Fraction. So what is the first thing I'm to do? Since there is fraction, you don't even concentrate on the square. Since there is a fraction, I will have to get rid of the fraction by first determining or finding my LCM. Now my LCM is the denominator, since that happens to be only the denominator in the relation. So my LCM is r squared. Now once I have my LCM, r squared, what do? You multiply each term by the LCM. That was what we did previously. So I am going to say r squared times p is equal to r squared times m over r squared plus r squared times k. So when r squared multiplies p, you have p r squared is equal to the r squared multiplying this fraction will therefore cancel out. Then I have 1 times m, which is n, plus r squared times k will give you kr squared. Remember we said that alphabets are arranged alphabetically, or variables are arranged alphabetically in an expression or in a relation. So now that I've been able to multiply each of the terms by the LCM, I have been able to get rid of the fraction. Now what am I making the subject? I am making r the subject. So let's look at the terms and try to see how many terms has r in it. Now this is pr squared, it has r. This is kr squared, it has r. So all the terms with the variable we are interested in should be grouped at one side of the equation. That is what we said. So I have r here, so let this term join this term here. So this is going to give you pr squared. When this term joins, it becomes minus kr squared, which is equal to m. Now we said that once it happens, where you have two terms having the variable you are interested in, what do? You factor out the common variable. So I have r squared here, I have r squared here. So we factor out the r squared. Once you factor, introduce a bracket. So r squared is out. What are you left with? P minus r squared is out. What are you left with? K, which is equal to m. From here, you can see that I want r squared, but the r squared is multiplying the bracket. So what do? You divide both sides by the bracket. So r squared bracket of p minus k is equal to m. Divide this by p minus k. You do the same thing to the right hand side. So this will cancel out. Now I have r squared is equal to m over p minus k. Now look at your variable. You have r squared. Now this is what I want. The r squared is now alone. But I don't need r squared. The question didn't say express r squared in terms of p, m, and k. But the question said express r. So because there is a square here, I will therefore introduce the square root so that the square can now be taken off for me to get the r. So I am going to introduce the square root on the left hand side, and I'll do the same thing on the right hand side, p minus k. Now once I introduce the square root here, this square root that I've introduced will cancel the square. And now what am I left with? I'm left with r. So now I am trying to express the r in terms of p, m, and k. So this is equal to the square root of m over p minus k. And now I have been able to make r the subject. Why is r the subject? Because r is the value I've solved for. And we can see that we have only r at one side of the equation. And so anytime you are solving a relation involving a square, let your interest be on the variable you are solving for. Try your possible best to let the variable stand alone on one side of the equation based on what we've done previously. Now once it is able to stand alone on one side of the equation, you get rid of the square by introducing the square root on both sides. And these examples will help us to understand the introduction or the basics in this. Now with this understanding, let's try to solve more examples. Don't limit yourself to only one source. Get more examples and change your subject and give it a try. Once you understand the topic, you have to give it a try. Now let's look at the situation whereby the the variable we are solving for has a square root. Now the ones we've solved for, the subject has square. Now let's look at the situation whereby it has a square root. What do? So let's look at the number 4. Given the relation m minus the square root of g is equal to k, make g the subject. So this is the relation you have. M minus the square root of g is equal to k. Now what is the subject, or what is the variable we have to solve for? We have to solve for this variable. We are making g the subject. But the g has the square root. That shouldn't be a problem at all. Wherever the g should go, let the square root, let it still be in the square root. Or it should still be in your square root. Now, for me to solve it easily and simply, I will take the square root of g to this side and bring the k to this side. You can also choose to take this to the other side. But once you do that, you can see that the square root of g becomes negative. So you will have to divide all sides by -1 so that you get a positive square root of g. But for me to solve it simply, or for us to solve it easily, let us take the square root of g to this side and bring the k to this side. So now we are going to say the k is positive. So when it comes or crosses the equal to sign, it becomes minus k, which is equal to, the g is also having negative sign in front of it. So when it also crosses, it becomes what? Positive square root of g. Now, you can see that finally, I have the square root of g at one side of the equation without any term close to it or any number apart from 1 multiplying it. So once the g is alone, but the g is in the square root, what do? I will therefore square both sides. So the square, you are going to square everything here. So we put them in a bracket to show that the square is for all of the terms. It's not for only one, which is equal to the square root of g also squared. The same thing once you introduce the square. If there is a square root, the square root will be cancelled out by the square. So now you have the bracket of n minus k all squared is equal to 2 has been able to, square has been able to cancel the square root. What do you have? You have j. Now, what is j? It is the subject. So therefore, j being the subject is n minus k all squared. And so you should know that once you are able to make the variable you want the subject, and that variable is in a square root, just introduce a square. Then you are good to go. Let's look at the last one and see if we can also try and reason or think outside the box. It says, make y the subject in the relation t is equal to 2 pi the square root of L over y. Now this is the relation. T is equal to 2 pi the square root of L over y. And what are you making the subject? You are making y the subject. Now look at where the y is. The y happens to be in a square root and is a denominator. The y is in a square root and is in a denominator. Now we cannot solve this with the idea of multiplying by LCM, and we'll say that the LCM is what? Is 1. No, you'll be wrong if you do that. So what do we do? Now, to make the work simple for us, let us get rid of the square root first. Get rid of the what? Of the square root first. So instead of me trying any difficult thing to do to make y the subject, I will first get rid of the square root. Now, how many terms do we have, first of all, in a question or in a relation? We have 2 terms. This is one term, this is another term. So we are going to square everything in this and square everything in the other term. So this will give you t squared is equal to, just put the relation here in a bracket, then L over y also squared. The interest is to get rid of the what? The square root, so that we can solve for y. Now once you put this term in a bracket, what does it mean? It means the square is affecting the 2, the square is affecting the pi, the square is affecting the square root. So we are going to say t squared is equal to, since the square is for this, the square is also for this, the square is also for this, it simply implies or means that you have 2 raised to the power 2, pi raised to the power 2, then the square root of y of L over y also raised to the power 2. That is the meaning of it, the expression. That is the meaning. Okay, so here we have t raised to the power 2 is equal to 2 squared is 4. Pi squared is pi squared. Because pi times pi is pi squared. So 2 squared is 4. 2 squared is 4, and pi squared is also pi squared. Now here, because we have introduced the square, what will happen to the square root? The square root will be cancelled out by the square. So you now have L over y. Then now you have your fraction, whereby your LCM is y. So you multiply this is 110 by y, and you multiply this also by y. So this is going to give you let's use the one that will be clear for us. So this is going to give you t squared y is equal to 4 pi squared L. Where did the L go? Where did the y go? We multiply this by y. Remember we said that when you have the LCM, multiply it 10 by the LCM. So this is being multiplied by y, whereby it will cancel out. Then this is multiplied by y, which will give you t squared y, which is equal to 4 pi squared L. Good. Now what are we making the subject? Y. But y is close. It's being multiplied by t squared. So what do? You divide both sides by what? T squared. So divide by t squared, divide by t squared. T squared cancel t squared. So y is equal to 4 pi squared L all over t squared. And this is your answer for that. So today we've looked at relation involving square and square root. We are trying our possible best to get you a very quality video so that you can benefit from it. And we said that a relation can have a square and can also have a square root. When it has a square, all you need to do is to target on the variable you are making the subject. Once you have that variable standing alone at one side of the equation, we've done the one without square root, the one without fraction, the one that involves brackets. So with that idea of the introduction of change of subject and also that of relations involving fraction, you can do this one. So just let the term with the variable you are solving for stand alone. Once it is alone and there is a square, you square root both sides so that that variable will now stand alone. But when it happens to be a square root, when the variable that is standing on its own that I'm making the subject is at one side of the equation, I will therefore introduce the square, and the square will get rid of the square root. We will draw the curtains down for today's presentation. When we meet again, we will look at substitution in relation, and word problem in relation to change of subject. Substitution in relation to change of subject. We need to know this before we go and write our standardized test examination, which is the BEC for 2024. If you have any question, you can drop it in the comment section. We will attend to you. Any contribution to, you can also bring it there. Please don't forget to hit the subscription button. You share the link to others to also benefit from this service. You can also sponsor this program by just any means that you want this program to also be known by others. Financially, sharing our links, sharing to people is even a sponsor that you are doing for us to also get to higher grounds. See you next time, God willing. Bye-bye.